In this video, I'm going to show you how to solve a typical problem that traditional methods refer to as the inverse compound rule of 3 or inverse proportionality of magnitudes. However, as I have already mentioned in previous videos, it's not correct to classify magnitudes based on whether their relationship is direct or inverse, because inverse magnitudes do not exist. Traditional methods are based on two physical theories that have not been proven, which are precisely that direct or inverse relationship between magnitudes. The problem with classical methods is that they are based purely on intuition, and they only teach in a mechanical way how to solve specific problems, but they have not been proven to work for every case in general. However, the method I am proposing here is one that I have actually proven to be applicable to any type of problem. I am leaving a link in the description to the articles in Spanish and English that have been approved by the scientific community as a whole, so you can verify that it has indeed been proven for any case. But in this video, I'm going to focus on showing you how to apply this method to a specific case. And it goes like this: 5 workers working 6 hours a day build a wall in 2 days. How long will it take 4 workers working 7 hours a day? Well, let's find out. The first thing we need to do is distinguish within the problem between the statement and the question. In the statement, we have that proportion of quantities that we're going to look at now, where there are no unknowns because we know all the data for each of the measurements, okay? And then in the question, where we will indeed find the corresponding unknown. For the statement on one hand and for the question on the other, we need to identify the quantities that represent resources so we can match them to the quantities that represent the final work we want to achieve. Alright, so in the statement it says, 5 workers, working 6 hours a day, build a wall in 2 days. That's the statement, because as you can see, they give us all the data for each of the measurements. Now, from this comprehensive data, from these detailed measurements, which specific measurements are considered resources? Well, we clearly have 5 dedicated workers, each contributing their efforts. We also have 6 productive hours available per day, providing a significant amount of time. And finally, we have a period of 2 full days, which allows for a considerable duration of work. And the combination of these 3 measurements, since they are of different magnitudes, that is, their dimensional elements are different because on one hand, we have workers, on another, we have hours per day, and on the other, we have days. The geometric combination, or according to the first algebra of magnitudes that we have to perform among these 3 magnitudes, is geometric multiplication, which we symbolize with an asterisk because we are not dealing with arithmetic, okay? We have not eliminated the magnitudes from these operations, we are working with magnitudes. And respecting the first algebra of magnitudes, we symbolize this type of multiplication with an asterisk. Alright, these are the 3 resources we have. What is the final work? A wall. And that wall is the final work. So here we already have the first proportion that refers to the statement. Now let's look for the proportion that refers to the question, which says, how long will it take 4 workers working 7 hours a day? Alright, following the same order in which the measures appeared in the statement, how many workers do we have? Well, first we have 4 workers, which is combined geometrically by multiplication with how many hours per day? 7 hours per day, which is again multiplied geometrically with how many days? That's where we have the unknown. Days. The magnitude remains the same, but what we don't know is how many of that magnitude we have. That is, how many days we have. And what is this equal to? The same wall. The final work doesn't change between the statement and the question. Perfect, so here we already have the 2 proportions corresponding to the statement and the question. What do we have to do now? If we divide each side of the equation member by member, we end up with a single proportion for the entire problem. I insist, we're operating with magnitudes, so that division can't be represented with a single horizontal line. We have to use 2 horizontal lines. Great. From here, what happens next? According to the first algebra of magnitudes, it has been proven that when a magnitude is divided by itself, the abstract number 1 is obtained. So, what do we have? Well, in this proportion we have workers divided by workers, which gives 1. Hours per day divided by hours per day, which gives 1. Days divided by days, which gives 1. And wall divided by wall, which gives 1. So, this entire proportion becomes a simple arithmetic operation, which is as follows: 5 times 6 times 2 divided by 4 times 7 times x. And this is equal to 1 over 1. So now, just by solving for x, what do we get? Well, x equals 5 times 6 times 2 divided by 4 times 7. And what does this equal? Well, it equals 2.14. 2.14 what? Referring back to the original measurement where we have the unknown x days, it's 2.14 days that it will take for 4 workers working 7 hours a day. If you want me to solve or set up a specific problem, leave it for me in the comments, and what I ask of you, please, is to help me spread the word about this method. Thank you very much.